Hello, you are welcome to New Focus Approach to Mathematics Basic 8. This is the revised edition. And in this lesson, we are looking at operations on sets. This lesson can be found in page 35. So with the operation on sets, we'll be looking at intersections and we're looking at union. Then we'll take a few examples. So let's look at intersection. Operation of sets has to do with intersection and union. That is where we bring two sets together. There's intersection, which we normally use a symbol this to represent, of two sets, let's say set A and set B, the set of elements common to both A and B. Take note of that. When we have two sets, element in set A and element in set B, those elements that are common to both of them become the intersection. And it is written as A intersection B. Okay, A intersection B. For example, if I give you a set called set A, we have B, 1, 2, 4, 6. Set B, we have 4, A, B, C, D, F. If I want you to find A intersection B, then we are looking at elements that can be found in set A at the same time in set B. And if you go through that, you will see that 4 can be found here, 4 can be found here, B is here, and B is there. So these are the two elements that can be found in both A and B, and they form the intersection. Now, when you represent this on a Venn diagram, then we can call this set A and set B. Okay. Now, the elements that are common in set A and B will be over here, right? These are the intersection. Now, after taking the intersection, then the element left in A only becomes 1, 2, and 6. And that of B only becomes A, C, D, and F, right? Let's take another example and see. Let's say you have set P defined as 1, 3, 5 and set Q defined as 1, 2, 3, 4, 5. What is P intersection Q? And here you can see that all the elements in P can be found in Q. And so the intersection is 1, 3, 5, which is the same as P. Now, when you want to represent this on the Venn diagram, here we have our P. And then P, we have 1, 3, 5. Then we have our Q, which is 1, 2, 3, 4, 5. But because we have 1, 3, 5 as intersection, then the leftover element for the Q becomes 2 and 4 and 2, or 2 and 4. You can see that here I didn't draw the two circles to overlap, and I made one inside the other because P is a subset of Q, and so the intersection will be within the set. Okay, now let's look at union of set. When we talk of union of set, what we are saying is that the union, which we use the symbol this, okay, not exactly U, but then it curves a bit like this one, of two sets. The union of two sets A and B is a set of elements that can be found in either A or B or both. So it can be either A or B or both. And it is written as A union B. And take note, union, we don't write it like this. Okay, we don't write the U, we don't write it as U like this. It's not done. It is this. Okay, good. Now let's take example. If P is defined as 1, 2, and 7, and Q is defined as 2, 3, 5, 6. What is P union Q? And so all elements that are in P and that are in Q, or that are both, or are in both P and Q. And so when we put all of them together, we have our 1, 2, 3, 5, 7, 5, 6, and 7. That becomes the union of P and Q. Now let's look at this question here. The question says P is defined as prime numbers between 1 and 20, and R is odd numbers less than 15. We want to list all the elements of P, okay, and that of R. Now when we say prime numbers between 1 and 20, prime numbers, we start from 2. Then we go to 3, 5, 7. Then 9 is not a prime number, so we go to 11, 13, 15 too is not a prime number. We go to 17 and then 19. So these are the prime numbers between 1 and 20. Then talking about R says odd numbers less than 15. Odd numbers less than 15. We have 1, 3, 5, 7, 9, 11, 13, 15. No, less than 15. So that means 15 wouldn't be part of it. So 15 is out. Then we bring our curly bracket. Good. Now the question says find P intersection R. So P intersection R will be equal to all elements that can be found in both P and R. And you can see that 3 is here, 3 is here, so we can have 3. 5 is here, 5 is here, so we can have 5. 7, 7, we can have 7. 11, 11, we can have 11. 13, 13, we can have 13. And that is all. Okay. Now we have to represent this on a Venn diagram. So we can have one set called maybe P, and then the other set, let's call it R. Now the intersection is 3, 5, 7, 11, and 13. Then what is left in P? We have 2, 17, 19. What is left for R is 1 and 9. And so this becomes the Venn diagram representing that. Now let's look at another question. Given that R is a counting numbers less than 10, and then S is factors of 12, find set R and X. So we want to write set R, the list of it. Counting numbers less than 10 means 1, 2, 3, 4, 5, 6, 7, 8, 9. So less than 10 means we don't include 10. Then S are factors of 12. So 12 we have 1, 2, 3, 4, 6, and 12. These are the factors. Then we have to find B, S union R. And S union R simply means we are going to have all the elements in both sets. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 12. So these are the union elements that are found in both R and X, and they appear in each one of them. So that is the answer for the union. Now we have to represent this using Venn diagram. Again, we can draw a Venn diagram for let's call it R. And then, is there any intersection here? Yes, there is intersection, so we can bring intersection here too as well. And so intersection is 1, 1, 2, 2, 3, 3, 4, 4, 6, 6, and that's all. So all this must be put in here. I don't have space to write them, so it will put in here. Then the rest you write what is left here. It will be 5, 7, 8, and 9. And what is left here will be just 12. And all others will be in the middle. And that makes the whole union. So the union is everything. Everything inclusive. Everything inclusive becomes the union. I'm sure this has really helped you to understand the operation on set. Thanks so much for watching.